Okay, so we're still in section 3.5, looking at rational functions and their graphs. I want to talk a little bit about arrow notation. We mentioned this in the last video, the previous video, where we were talking about vertical asymptotes. Well, as discussed in that video, this notation, x pointing to an a that has an exponent that's a plus sign, is a shorthand way of writing x approaches a from the right. Similarly, x with an arrow pointing from it to a, which has an exponent that is a minus sign, is our notation for saying x approaches a from the left. Here we write x with an arrow pointing to an infinity symbol, meaning x approaches infinity. That is, x increases without bound. Here we write x with an arrow pointing to negative infinity, and we would say x approaches negative infinity, and that means x is decreasing without bound. So let's take a look at a graph of a rational function. So here's our graph, and I want to just talk about different areas of this function where we see our arrow notation. And remember, we use arrow notation to describe the behavior of some functions. So let's take a look at what we see here. Now here we notice that x is decreasing without bound. So notice here x is going to negative infinity. Here we see that x is approaching negative 2 from the left. So notice that's how we would write that. X approaches negative 2 from the left. So that would be the way we would write that. These are the symbols we would use. X, an arrow pointing from x to the negative 2, and then an exponent of a negative sign means approach from the left. So here x is approaching, trying to improve my writing here, negative 2 from the left. Here I have x approaching negative 2 from the right. So that's actually what's happening to my x's here. X is approaching negative 2 from the right. Here, x is approaching 2 from the left. Here, x is approaching 2 from the right. And here, x is approaching infinity. So another way to say this is that x is increasing without bound. So this is our arrowhead notation. Now a lot of times what we'll want to do with this notation is we'll want to talk about what is the function doing as x is doing these various things. So arrowhead notation can also be used to discuss what the function is doing as well. So one way we would discuss this is we'd say as x goes to negative infinity, we can see that the function is getting closer and closer to the x-axis. That actually means, so as x goes to negative infinity, f of x, which remember that represents my y values, is going to 0. So if my function is getting closer and closer to the if my function is getting closer and closer to the x-axis, that means my y values are getting closer and closer to 0. And actually, these are going to 0 from below. So a lot of times to indicate that, we would use the negative symbol as an exponent. So notice y is coming to 0 from below. So when I'm talking about y's, the plus and minus as an exponent means from below or from above. When I'm talking about x's and I use the negative or the positive symbol as an exponent, I'm talking about from the left and from the right. So as x goes to negative 2 from the left, f of x is decreasing without bound. So I would write f of x is going to negative infinity. As x goes to negative 2 from the right, f of x is going to positive infinity. It's increasing without bound. So notice how the y values are getting larger and larger and larger. Here the x values are getting more and more negative. The y values are getting more and more negative. And that's why we say f of x is going to negative infinity. As x goes to 2 from the right, or let's do from the left first. From the left, here, that's what's happening here. Notice f of x is decreasing without bound. Our shortcut for writing that is to write f of x, an arrow pointing from f of x to the negative infinity symbol. So notice how the y values are getting more and more negative. As x goes to 2 from the right, f of x is increasing without bound. So the values of x are getting larger and larger and larger. So as x goes to 2 from the right, my y values, my function values, are getting larger and larger and larger. And then as x goes to infinity, f of x is going to 0 from above. So f of x, the y values are getting closer and closer to the x-axis. In order the x-axis is actually where y is 0. So that's why we say the function values are going to 0, and they're going to 0 from above. They're always a little bigger than 0, but they are approaching, those y values are approaching 0, but they are bigger than 0. Remember when I had my x approaching negative infinity, remember here my y's were also approaching 0, but they were approaching 0 from below. And so I use the negative sign as an exponent to say y's are approaching this value from below the value. I use the plus symbol as an exponent to say the y's are approaching this value of 0 from above. So they're approaching the x-axis, and they're always a little bit bigger than 0. These y values are getting closer and closer to 0 while always being larger and larger than 0. Alright, so this is our arrowhead notation, and it allows us to make certain statements and write them very succinctly.